We'll start by designing a fidget cone for 3D printing and finish by creating this simple animation. Keyboard shortcuts will appear in the bottom left corner as they're used. We'll start this fusion project with the center diameter circle, sketched around the origin on the predefined horizontal construction plane. The exact dimensions aren't critical. You can use your own if you find my 80mm base too big or too small. Save time by going straight from the sketch environment to the extrude command without closing the sketch. I'll extrude it 80mm and set the taper angle to -15 degrees so it narrows inward. I'm not focusing on perfecting the top design at this stage. We need 2 copies of this body, both positioned in the same spot. Using the usual copy-paste shortcuts in the browser works perfectly. Just paste and press Enter to confirm without moving the body. Having 2 identical bodies in the same spot increases the chance of mistakes. So I'll apply 2 different glossy plastic appearances to make it easier to follow visually. Adding the colors through the browser saves time, as both bodies are in the same place. I can apply appearances quickly without the need to show or hide bodies. Body 1 is the blue body and body 2 is the red one. We'll keep body 2 hidden and continue working on body 1. We'll continue working on the bottom of the design. I'll create a linked projection on body 1. This way, if we update body 1, the earliest body in the timeline that body 2 is based on, the projection will update automatically. Projecting the boundaries from body 1 isn't strictly necessary, but it helps keep everything connected and makes it easier to locate body 1's exact boundaries. We're offsetting this projected sketch by -5mm to keep our next closed sketch profile from reaching the edge. Otherwise, it would remove too much material later on. You'll see why soon. Since this offset circle isn't part of the actual design, I'll select it and turn it into a construction line. Think of it as a guide that doesn't affect the 3D geometry. We need guidelines for our upcoming sketch that will cut through the fidget cone. Start at the origin and sketch them outward. The length and angle don't matter yet. Once the lines are in place, you can dimension them either with an angle or using a formula. This is a design choice. I'm dividing my circle into 12 sections, which gives me 30 degrees per segment. Since these whole lines aren't part of the final design, I'll turn them into construction lines. As usual, I prefer using shortcuts, but you can also find the option under the line type setting if you'd rather click. Now it's time to get creative with a fit point spline. I'll share some key tips, but I won't spend time perfecting or fine-tuning the sketch. No one sticks around to watch that part. We'll start by roughly placing the spline, then break the construction line on the left side since part of it needs to be part of the closed profile we're creating. The break command suggests a good breaking point and will convert that segment into a regular line. And yes, some of you might be thinking it was unnecessary to turn the left line into a construction line in the first place. That's true, given that we deleted the part we didn't need. Use the mirror command in the sketch environment. Select both the line and the spline as your objects and use the vertical construction line in the middle as the mirror line. Once you press OK, you should have a closed profile. The nice part is you can adjust the entire sketch, including the mirrored side, just by editing the original line and spline. One thing you should definitely be aware of is the ability to adjust the spline curvature using the green handlebars. This tool is intuitive and fun to use, allowing you to keep the number of spline points to a minimum while still maintaining plenty of flexibility. You're on the right track if you have a projected circle linked to the original cone body an offset inner circle turned into a construction line as a limit for your sketch, and a closed profile that resembles the one we're aiming for. We need a line with the same height as the cone for upcoming commands. I'm setting it to 80 mm, the same height as the cone, but it's not linked to the cone, meaning future changes would require adjustments in different parts of the model. While outside the scope of this tutorial, it's worth mentioning that incorporating user parameters into the design would allow us to update multiple parts with minimal input. I'm turning this line into a construction line out of habit since it isn't part of the design, but in this case, it doesn't make a difference. You'll achieve the same outcome if you leave it as a regular line. This is the perfect time to save your project just before we dive into advanced modeling commands. Use the solid modeling sweep command to sweep a closed profile. Simply select the mirrored profile and then your newly created line as the path. The cut operation is what we want, but you'll also need to set a twist angle. I set mine to a full 360 degrees, but feel free to experiment with different solutions as you perfect your fidget cone. The profile only starts cutting through the edge of the cone once we reach a certain height. This is why I didn't create a closed profile that extends all the way to the edge of the projected line. The 5 mm distance used in this tutorial isn't optimized. The focus here is on the overall workflow. You're encouraged to try different dimensions and see what works best for you. Use the blue axis or select the vertical line in the middle of your body by clicking the edge with your left mouse button when the small menu pops up. I'm setting my quantity to 6, but I've seen other tutorials where different quantities are used for fidget cones. Your computer might take a little time to compute this complex sweep cut operation and evenly distribute the circular pattern around the model. This is why I recommended saving earlier. Depending on your computer's capabilities and the complexity of the model, heavy computations can increase the risk of a crash. When you turn the visibility of the red body 2 back on, you'll notice conflicting areas in the geometry. Specifically, the red striped red and blue regions overlapping. To resolve this, use the combine cut operation. Set body 2 as the target body, since it's the main body we're modifying. Body 1 will act as the tool body, as it has more developed geometry compared to the original cone. Make sure the operation is set to cut, because we want to remove material. Also check Keep Tools. We want to keep body 1 as part of the design. Once applied, the overlapping areas should be gone. However, you may still notice that body 1 and body 2 fit too tightly. For proper assembly or function, we will introduce small gaps between them for clearance. I'm saving my project at this point to have a version backed up before performing this operation. We're doing this because we need a small gap between the red and blue bodies. If you look closely, you'll notice they're currently too tight due to the previous steps. To fix this, we'll hide the red body again and start a press-pull operation. Here, I'm selecting just one side, but the exact distance you choose depends on several factors, like your design, your 3D printer, its settings, and the materials you're using. Be sure to check from different angles to ensure you've selected all necessary areas before applying the adjustment. I'm setting the clearance to negative 0.2 mm and you'll see the complex computation begin right away. This computation took about a minute on my system, so we'll skip ahead and continue with the 3D modeling. Turn the visibility of body 2 back on and inspect your model. You should now see a small clearance between the parts, giving the bodies a better chance of fitting together properly. Next, we'll convert both bodies into components and animate them in the animation workspace. A quick way to do this is by selecting each body in the project browser, then right-clicking and choosing Create Components from Bodies from the context menu. The settings carry over from the design workspace to the animation workspace. Since I don't want the origin to be visible, I'll quickly jump back to the design workspace and turn off its visibility. The animation workspace is straightforward and will keep things simple in this tutorial. We'll begin by setting the camera angle for the start of the animation. The recording will start from this angle. Next, I'll set the duration for the first action. I'll set it to 10 seconds. The animation starts with the initial camera angle and ends with the updated camera position after setting the duration. The green bar indicates that the recording is active. You can use the play button to preview the animation so far. The camera movement is in place. Now let's add some part movements. Next, I'll animate the upward movement separately. Body 2 starts at the bottom at the beginning of the recording, so we'll set the timeline to the end of this 10-second duration and position body 2 where we want it to be. I'll set the height to 80 mm, which is the height of the cone. Everything looks good, so now we'll set up the rotation. We're already at the end of this recording duration, so we'll now tell Fusion to apply a 360-degree rotation at this point. This matches the rotation used for the sweep command's twist angle 6 minutes and 20 seconds into this tutorial. The preview looks good, everything seems correct, and we're ready to publish the video. Publishing is simple. Just hit publish, choose your settings, press OK, and select the location for the export in the upcoming steps. If you enjoyed this tutorial, I think you'll like this one too. Thank you for watching, and I'll see you again soon in another Fusion tutorial.